We're going to look at something called a correlation coefficient, and we're also going to practice line of best fit with the calculator, which is called linear regression. So for the warm-up, choose 2 points and find the slope. Find the y-intercept and write the equation in slope-intercept form, y equals mx plus b, and use your equation to predict your resting heart rate if you exercise 10 hours, it should say, in a week. All right, so let's do A first. Choose 2 points, and when I say 2 points, you have to find them on your line of best fit. They don't have to be the exact data points. So let's find 2 good points to use. Here's a pretty good point to use that's right on the line, and this one's pretty good too. Okay, so again, we're looking for like whole number points right here. Okay, so to find the slope, it's rise over run. It's a negative slope because it's going down, and it's going down. And notice this is scaled by 5. So 5, 10, 15, 20, 25, 30. Wait, 5, 10, 15, 20, 25. So it went down 25, and it went over 1, 2, 3, 4, 5, 6. So there's our slope, negative 25 over 6. We can leave it as a fraction, or if you want to change it to a decimal, we can divide negative 25 divided by 6, and it's about negative 4.16 repeating. So there's your slope. Find the y-intercept and write the equation in slope-intercept form. Okay, the y-intercept is right here, and so our equation is y equals, there's 2 ways to write it, 80 minus 4.16 repeating x, or we can write y equals negative 4.16 x plus 80. So for every hour of exercise, it goes down about negative 4.16 beats per minute. Use your equation to predict your resting heart rate if you exercise 10 hours in a week. Okay. So I'm going to write negative, or y equals 80 minus the 4.16 repeating x. And we have to figure out 10 hours. Is hours x or y, and we can see that it's x here from the graph. So we have y equals 80 minus 4.16 repeating times 10. I'll plug in for 10 right here. Whoops. Okay, so let me type that in. 80 minus 4.16 times 10, and the answer is about 121.6 repeating. Okay, so what we've done here is we've taken a look at a line of best fit. We found the slope and the y-intercept, and we used that equation to predict our heart rate. So we have 3 learning targets today. Can you create a scatter plot on your graphing calculator? Can you find the line of best fit on your calculator? And can you find the correlation coefficient on the calculator? And so all the steps are right here for those 3 learning targets. And so this is what we're going to practice. And if we get stuck, we can look back at these steps here to type in. Okay, so first thing we're going to look at is positive correlation. For each set of data, use the graphing calculator to create a scatter plot and calculate the line of best fit and correlation coefficient and describe the correlation as weak or strong. So let's do the first table here. And again, we are going to make a scatter plot. And so if you get stuck, scatter plot is right here. We're going to open a list in spreadsheets, go home, new document, add a list in spreadsheet. And we're going to type this in. So we have to name our first row X and our second row Y, and we're going to type in the numbers that we see right here. So it goes 2, 3, 6, 7, 8. So I'm going to type that in 3, 5, 6, 7, 8. 3, 5, 6, 7, 8. And the Y value is 2, 4, 5, 6, 7. 2, 4, 5, 6, 7. All right, we are going to now create the scatter plot. So we're going to hit Control Doc to add a new page and add a data and statistics. And we have to click to add our X always goes on the bottom, our independent variable, and our Y goes on the side. Okay, so it looks pretty linear here. And then to make a line of best fit, okay, so we're going to sketch that scatter plot. So we would sketch this right here. I'm not going to sketch it. Let's find the regression equation. So we're going to go to Menu, Analyze, Regression. Let's show linear, and there's 2 of them to choose, and so here's the equation. Y equals 1 x plus -1. So that's telling us the y-intercept would be -1, and the slope is about 1. So let's write that down right here. Again, if we sketch it, it kind of looked like this. The equation was 1x minus 1. And now we have to find the correlation coefficient. So we're going to hit Control Enter and go back to this page and go to Menu, Statistics, Stat Calculations, Linear Regression. And here we have to choose our x variable, x, our y variable is y, and go to OK. And it gives us the equation. Here's our slope. Here's our y-intercept. And the correlation coefficient is 1. And so let's write that down. And it asks, is it a pretty strong relationship? And we're going to say, yes, it's strong. It makes a pretty straight line. So it's a very strong relationship. Okay, let's practice that again with this table right here. So I'm going to, again, open a new document. Don't save unsaved. Add a list and spreadsheet. Again, label it X and label it Y. And we're going to type in our table here, 12578. Okay, and then we'll type in our Y values, 28193. Let's see what this looks like. Let's go to Control Doc, add a data and statistics page, select our X variable, select our Y variable. You can see that this is not a very strong relationship. Let's do our menu, analyze regression. Oops, did I pick the right one? I don't think I did here, so let's delete this guy. Okay, so again, menu, analyze regression, show linear. Okay, so here it is. And you can see that that's our line of best fit. We have about the same amount of points above and below. Let's first sketch the graph. So it was something that looked like that. The regression equation is 0.11, I'll estimate, not estimate but round, x, and plus about 4.08. So this is the y-intercept. The slope is not very big. So again, our line here looks like this, here it looks like this. Let's look at our correlation coefficient. So again, if I hit Control and arrow over to this page and go to Menu, Statistics, Stat Calculations for our linear regression, and select our x and y value, we can see that our R value here is 0.09. That's a lot smaller than 1 here. So R is 0.09, which means that our correlation is very weak. All right, so we're going to look at a few more situations, and we're going to find that if our correlation coefficient is 1, that everything fits on the line. And if it's anything less than 1, between 0 and 1, if it's close to 0, nothing really correlates. Okay, so that was positive correlation. Let's look at a negative correlation. We're going to do the same thing here. So again, we're going to put our data in a table and find the correlation. So again, new document. Don't save, unsaved. We'll add a list and spreadsheet. Again, title it X and Y. Okay, and we're going to do 13789. And then for our Y values, we'll do 97321. Okay, we'll hit Control Doc, add a data and statistics. We'll select our variables, X and Y. And there's a negative correlation, and it's a pretty strong correlation. If we go to Menu, Analyze Regression. Oops, again, I picked the wrong regression. Let's try that again. Menu, Analyze Regression. Let's look at the linear. And here it is, negative x plus 10 is our equation. So again, our scatter plot is pretty strong straight line here. And then if we write the regression equation, I'll just squeeze it on right here. It's negative 1x plus 10. Let's find the R value and see if it's weak or strong here. So again, Control arrow over, Menu, Statistics, Stat Calculations, Linear Regression, select our X and our Y. And we can see that our R value is pretty strong here at negative 1, which means it has a strong negative correlation. So this is negative 1. All right, let's try one more scatter plot here. I'm going to just open a new document. Okay, so this is x, this is y. And we're looking at 2, 4, 5, 7, 8. Okay. And we'll look at our data 9, 5, 8, 4, 3. Okay, and let's go to Control Doc, add a data and statistics. Click to add variables. Okay, so this goes down if there's a negative correlation. Let's draw linear. But it's not as strong. Everything doesn't fit on the same line. So if we write our y-intercept, or not our y-intercept, our line, it's negative 0.9x plus 10.5. So again, we had some points above and below, something like that, where this is on the straight line. So we have y equals negative 0.9x plus 10.5. Our R value should not be as, will be closer to 0. So if we go to Menu, Statistics, Stat Calculations, select our variables x and y. We can see our R value again is negative because it's negatively correlated. As one goes up, the other goes down. But it's a lot less than 1. It's negative 0.8. Okay, last type of correlation. No correlation, so I'll show you what one of those looks like. Okay, let's open a new document. No. Okay, so we have x, we have y. Let's type in our numbers here. We have 1, 3, 7, 8, 9. And our y values are 9, 0, 9, 0, 9. Okay, let's see what this looks like. Control Doc, add a data and statistics. X, oops, I want this to be X, this to be Y. And you can see that there's nothing really good about this. There's nothing correlated. There's no relationship. So if we show linear, there's our equation. I do want to show you the R value though, so we can see this line of best fit. It's not really close. But the R value, so Control, also Menu, Statistics, Stat Calculations, linear. Our R value here is very close to 0, 0.02. Okay, so I'm going to write that down. R equals 0.02, and it's a weak correlation. This is the correlation coefficient, and it's weak. Okay, so we're going to summarize here. Look back at your correlation coefficients. The maximum value of R is 1, and the min is -1. And 1 means it has a strong positive correlation, which means as x goes up, y goes up. This is a strong negative correlation, which means as x goes up, y goes down. But they're strongly correlated, which means a lot of points are on the line. A scatter plot of 1 looks like this. As x goes up, y goes up, and everything's on the line. A scatter plot of -1 looks like this. Again, everything should be on the line or close to the line, and it has a strong negative correlation. As x goes up, y goes down. If the scatter plot is 0, it's all scattered about. And you can have everything in between too. So I might have one that's pretty strongly correlated like this, and this might have a correlation coefficient of 0.8, which means it has a pretty strong correlation. This is close to 1, but not everything's on the line. Likewise, I can have one that looks like this, where it's pretty negatively correlated, but let's say that's -0.6, which means it does have some relationship here. It's not 0, and it has a negative correlation. As one goes up, the other goes down, but it doesn't make an exact straight line. So in our assignment today, we're going to practice these ideas and practice more linear regression tomorrow.